All right, so the last thing we learned was how to solve absolute value equations. This video is going to be on solving absolute value inequalities. So part of it will feel a little bit similar to what we've already done, and then part of it's going to feel a little bit different. We're taking the ideas, we're going a little bit further. We're looking at situations that are just a little bit trickier. So if you recall, this notation, the absolute value of x, means the distance from x to 0. And that's why when we work with absolute value, we always say that you just take the number inside and you force it to be positive because distances are always positive. Yesterday, when we were talking about equations, we said the absolute value of x equals 3 means that the distance from x to 0 is 3. And so we got specific answers. In this case, x could equal positive 3, x could equal negative 3. There's only two specific answers that would work for that problem. Once we start working with inequalities, it's the same as what we've experienced with linear functions as well, is that when we work with inequalities, we have lots and lots of answers that will work. We have a range of answers. So when you say something like the absolute value of x is less than 5, what you mean is the distance from x to 0 is less than 5. And if you think about that, there's a lot of numbers that are in between there, especially when you start taking into consideration that decimals are okay to use as numbers. So if we have 0, and we're looking for numbers that are within a distance of 5, we could have -1 and we could have +1. Both of those numbers are within a distance of 1 to 0, so that's within a distance of 5. You could also have 2 and -2, those are within a distance of 2 from 0, so those would also work. So now we've got 1, 2, 3, 4, 5. We've got 5 different answers that would all work, that would be okay. In fact, if we keep extending our number line, we can go up to 3. That's a distance of 3 from 0. 4, that's a distance of 4 from 0. We can go all the way up to 5, but we can't include 5 because the distance has to be less than 5. So we could use 4.9. We could use 4.99, 4.999, but we can't get all the way to 5. Okay, so all those numbers get used. We're going to do the same thing in the opposite direction. -3, -4, -5. So these are all the different numbers that can be used. I only wrote down the whole numbers, but all of the decimals and fractions that are in between there, those are also good answers for the problem. So we're going to say that the x value is somewhere between -5 and 5. It can't equal 5 exactly, it can't equal -5 exactly, but as long as it's a number that's in between those, then it will work, where the distance between that number and 0 is going to be a distance that's less than 5. All right, down here I'm going to say the absolute value of x is greater than or equal to 4. So the distance from x to 0 is greater than or equal to 4. So again, I'm going to draw that number line. We're talking about the distance to 0, so I'm going to start with 0 in the middle. And it says the distance is greater than or equal to 4. So 1, 2, 3, 4. There's 4 right there. It could equal a distance of 4. So 1, 2, 3, 4 right there. Could equal a distance of 4. Or the x value could be more than a distance of 4. So here 5, that would be a distance of 5 from 0. A distance of 6 from 0. So it can be 4 or anything more than that. And then we can do the same thing in the opposite direction. -5 would be a distance of 5 from 0. -6 would be a distance of 6 away from 0. So everything going this direction. So here we would say x is less than or equal to -4, or x is greater than or equal to 4. So you see that when we're dealing with absolute value inequalities, the answers, there's two very distinct answers. We have one that's sandwiched. It's between -5 and 5. And then we have one that's kind of going the opposite direction, where it's less than -4 or greater than 4. So two very distinct things. And here is how I remember what the difference is. I look at the symbol once I've simplified the problem all the way down to here where I have the absolute value and I've got the number. Once I get to this point, I look at the symbol, and if it's a less than symbol, I write less than. And I think about the than. I'm going to put that in a color, maybe make it bold, put a star there, do something so that you notice it. This means we're going to have the sandwich going on. It's between one number and another number. It's between two numbers. That's what less than means. When you look at this sign, that's a greater sign. So we're going to think of this as great or, greater. It's a greater than sign. And that's when we're going to say it's going one direction or the other direction. So less than, it's in between those two numbers. Greater, it's going opposite directions. Okay, let's go ahead and do a couple example problems where they're a little bit more complicated. We have to do some more steps than this so you guys can see it in action. So for the first problem, we're going to do -4 times the absolute value of 3n plus 6 is less than or equal to -24. Now, notice my first step was not to commit to which one of these it is because I do not have the absolute value sign alone yet. So the very first thing I need to do is that one process we talked about with solving equations where you see if there's anything you can add or subtract to the other side, and you see if there's anything you can multiply or divide to the other side. So when I look at this problem and I see that the n is right over here with my absolute value sign, I don't see a number that I could add or subtract to the other side, but I do see a coefficient that I could multiply or divide to the other side. So I'm going to divide by -4 and divide by -4. And this is where you have to be careful, because if you guys recall from working with inequalities in the past, if you ever divide by a negative number or multiply by a negative number, you have to switch your inequality symbol. Okay, so this is something that I would write off to the side. Remember, so if you multiply or divide by a negative, switch your inequality sign, or your inequality symbol, I should say. Okay, switch your inequality symbol. So it was less than or equal to, I just switched it to greater than or equal to. Okay, at this point, I can go ahead and look at my symbol, and I see that this is a greater symbol, greater. So that means that we're going to be going two opposite directions. So I'm going to say 3n plus 6 is less than or equal to -6, or 3n plus 6 is greater than or equal to 6. And you'll notice that when I set up these equations, I have my arrows going, you can see they're going opposite directions because I want to show that it's not a sandwich. They're going opposite directions. They're going away from each other. So now I can go ahead and kind of solve these like normal. So I will subtract 6, and I get 3n is less than or equal to -12. Divide by 3, n is less than or equal to -4. Okay. Then over here, I'll minus 6. 3n is greater than or equal to 0. divide by 3, n is greater than or equal to 0. So again, you can see that when I get down at the end, my arrows are going opposite directions. So my final answer for this problem is that n is less than or equal to -4, or it's greater than or equal to 0. All right, for the next example, we have 6 plus 7x plus 2 is less than 52. So again, we're going to see if we can add or subtract anything to the other side, and then we're going to see if we can multiply or divide anything to the other side. I can see that there's a plus 2 onto the end there, so I can subtract 2. All right, and here when I look at my symbol, my absolute value is all alone, so this is the time when I start looking at my symbol. My symbol is a less than. It is less than. So I'm going to go ahead and write this as a sandwich. We're going to sandwich this between 50 and -50. So I'm going to say that was 6 plus 7x is sandwiched in between -50 and +50. And a lot of students will get confused when they write the sandwich inequality about which direction their arrows are supposed to go. They always go this direction. They always go pointing to the left, and they have to be the same. They're both going the same direction. All right, so now I'm going to go ahead and subtract 6, subtract 6, subtract 6. And I get -56 is less than 7x, which is less than 44. So now I'm saying that 7x is in between -56 and 44. And now I can go ahead and divide by 7 all the way through. And I get that x is in between -8 and 44/7. All right, here is our third example. We've got 5 minus 7 times the absolute value of -9x plus 10 is greater than -51. Okay, so first step, is there something I could add or subtract over to the other side? And there is. I can minus a 5. Now you'll notice that when I subtract a number, I don't flip the inequality. It's only when I divide or multiply by a negative number. That's the only time I flip it. So now I'm going to go through and divide by that -7. And now, because I divided by a negative number, I have to flip the inequality this time. So that's greater than 8. No, I didn't flip it. It was greater originally. Now it's less than. Okay. And now I've got my symbol. I can see that this is a less than symbol, so less than. That means I'm going to make a sandwich. So I've got -9x plus 10 is sandwiched in between -8 and +8. My next step is going to be to subtract the 10 so that I can get the x closer to being by itself. And then this very interesting thing is going to happen where we're going to divide by a negative again, and now we're going to have 2 signs to flip. So I'm dividing by -9, dividing by -9 all the way through. So negative 18 divided by negative 9 is 2. I flip my sign, x, I flip my sign, and I get 2/9. And at this point, for me as a math teacher, I know what these are supposed to look like, so this looks kind of wonky to me. It's like somebody put something in alphabetical order, but they did it backwards or something, where it's like, I can see the pattern, but it's off. So before I circle my answer, I'm going to go ahead and say that 2/9 is less than x, which is less than 2. I'm just going to go ahead and put it the right way because it feels a little bit off to me. Okay, so the smaller number and then the larger number. And you can see that when we look at this, the point, that's always the smaller side. The point points to the smaller number, and you open up to the larger number. So you can see I'm still pointing at the smaller number. It's still opening up to the larger number. I just switched it so that the answer made a little bit more sense to me. All right, example 4. Eight minus 9 times the absolute value of 6n minus 4 is less than negative 10. So again, our first step is going to be to add or subtract to the other side. So we're going to subtract 8. Negative 9 times the absolute value of 6n minus 4 is less than negative 18. I'll go ahead and divide by the negative 9. And since I divided by a negative number, I have to flip my inequality symbol to go the opposite direction. And that's just 2. And this symbol right here is a greater symbol. So it's going to go one direction or the other direction. So we have 6n minus 4 is less than negative 2, or 6n minus 4 is greater than positive 2. So less than the negative version, greater than the positive version. I'll go ahead and add 4. 6n is less than 2. Divide by 6. 2 over 6 is a fraction that can simplify. I can divide by 2 on the top and the bottom, so n is less than 1/3. Divide by 6. So n is less than 1/3 or greater than 1. So you'll notice that when I do these problems, I had a bunch of problems that didn't have an equal sign with the inequality. But if I do these problems, if there's an inequality in the problem that has the equal to with it, then I'm going to have an equal to in my answer. So you'll notice this one had an equal to in the problem, so I made sure I had the equal to's in my answer. I just matched that notation. And then here, when we just had a greater than sign, then we just had the symbol there. We didn't have the equal to. So make sure that you watch out for that and put the little line underneath it to include the number if it's appropriate.